Hello, everybody. We're still talking about the extractive distillation in Aspen Plus, and we are still solving this example. So, in the previous video, we saw how we were able to go beyond the azeotropic composition by using a solvent, which was glycerol. And we found that the output here was the solvent with water, and we wanted to go through the rest of the flow sheet, which consists of the solvent recovery unit, which is just a simple distillation column, and to recycle this solvent after dehydrating it or after removing the water from it. So this is going to be the topic of this video. The separation of the components of this stream, which is mainly water and glycerol, is going to be a very simple separation. If you try to plot the TXY diagram of water and ethanol and glycerol, or the XY diagram of water and ethanol, you see that this is how the XY diagram looks like. And we have a lot of space here, and the difference in volatility is very high, so that I can achieve this separation with very small number of stages in distillation column. And even if you leave it in open air for a few hours, you can get almost pure glycerol out of this. So the separation is not going to be difficult. And if you try to use the shortcut column, you'll find that it's going to give you like 4 or 5 stages, something like this, maybe less. So that's why I went directly to the rigorous column. I used 7 stages and normal conditions of total condenser, catalytic boiler, vapor liquid phases, the standard convergence. I used 0.5 reflux ratio. You can even use less and it's gonna work. So it's not something specific about this number. The only specification that I carefully used was the bottoms rate. It's going to be like what we did before in the extractive distillation column when we used the distillate rate in I think the previous video. Because we used the distillate rate instead of the distillate to feed ratio, because we knew that the amount of ethanol that we want to get out of the column is this number. So this is the same here. I know the amount of glycerol in the stream was 128 point something, so I wanted the bottoms to be 128 because I know there are some of the glycerol is gonna be entrained with the top product, so I'm gonna lose some of the glycerol with the top product. So that's why I use the specification as the bottom rate, which is 128 kilograms per hour. And I ran the simulation, and for the stream results, I found that for the glycerol recovery, oops, I did something. Yeah, so this is it. The mass flow rate is almost all the glycerol that I had is here. I lost some of it, and the water is almost all the water is in the top product. For the mass fractions, I got almost 100% glycerol. It's 99.996, so it's high purity glycerol. So the point now is to I didn't do this in the video because it's a very simple thing, and we did more difficult distillations before, so I don't want to waste time in doing this. I want to concentrate more on the recycle because it's kind of tricky. So the point now is that we need to take this stream and use it as a feed to this column instead of the feed, the glycerol feed. But before we go ahead and do this, you need to think about what steps that you need to follow so that the software understands what you want to do. And this is a very important point that I want to stress on in this video. First, one idea that may come into your mind or jump into your mind is that I'm gonna take this stream, connect it to the column, and delete this stream. This is a big problem, because if you do this, then there is no source for glycerol to the column. This might be okay, but it's not, but it might be okay in case of the steady state. So you have already glycerol in the column and you're running the columns and it's recovered continuously. But in the very beginning, you have to have a source of glycerol to the column. If you disconnect this stream, then you don't have any source of glycerol to the column, and it cannot start the calculation. There is no way it can start the calculations. So this is the first thing. So you cannot delete this column, this stream. The thing that you can do is to mix this and this so that you have a mixture of both is the feed to the column. So this is what I'm gonna do, is to disconnect it from here, get a mixer, connect it to the sorry, I'm just gonna make it a little smaller, and then take this as the feed to this mixer. This is the feed to this mixer. I didn't connect it, I'm not sure. Oh, I connected the other. Oh yeah, this is the feed. Yeah, this is right. Just wanna okay, I think it just needs to look the other way. So anyway, it's not a big deal now. I can fix it later. Anyways, so I have this stream is the feed to the mixer, along with the recycled stream from here. Now I wanna get the output of this column of this mixer and use it as a feed to the column. The column does not understand is that this is replacement to the other stream, so I have to make sure that you tell him that this is going to the same place. I'm gonna call this the glycerol to column so that I can differentiate, and this is glycerol mixer. And now we sorry. Okay, so now we need to make sure that the process is gonna go as we want. So what I wanna do is to make sure, or I wanna check is that this stream is 128.8 kilograms per hour, and the purity of ethanol here is the same, because this is the main target of the whole flow sheet, is that to get ethanol with high purity. The rest of the process or the flow sheet is just making sure that I make better use of the money instead of wasting the resources. I'm making better use of them. So I'm gonna run the simulation. It's missing something important, but I'm gonna run the simulation because I want you to see what problems that we are gonna face. It's displaying errors, and this is something I'm expecting. It's saying something about the solver. When you get errors about the solver, it has to do with design specs or flow sheeting options in general. The design spec here is saying that I'm changing the flow rate of the feed so that I can get the methanol purity as 99.5 as I wanted. This is okay in case of having this stream going directly into the column, but in this case I don't have this the flow rate. I mean, the stream is not going directly into the column. So I have already put the flow rate of ethanol or the glycerol to 128.8 here, which I got from the design spec in the previous video. So this design spec does not have any importance now. I'm not getting anything new from it. So I have to deactivate it or delete it. Which one of I personally prefer to deactivate it because I might need it later. So instead of doing everything from the very beginning, I can just stop it from working, and I have it already here. So if I run the simulation now, I'm not gonna get the error of the solver because it doesn't have any design specs now that cannot be working or cannot achieve the target. So it's now working, and now I want to check if it's doing really what I want or not. So I'm gonna check the extractive distillation stream results. The mass flow rate of the feed to isotrope or the feed of ethanol and water is 200. The glycerol to column is 328, and this is a huge number. I know it has to be 128, but it's now 328, and this means that there is something wrong I did, and I want to understand what's wrong. So if you follow the units one by one, you'll find that again this is 328. You'll find that the mass fraction of glycerol is gonna, or of ethanol is gonna be even higher than 99.5. So I'm getting 99.8% ethanol because I'm using huge amount of solvent that is almost 2.5 times the amount I used in the previous video. So it's improving the purity, of course, but I don't want that. And again, if we take a look here at the extractive distillation about the bottom product, this is the bottom. It's 344. It used to be 144. So there's something not right here. And the glycerol recovery stream results here, I have 344, and this is the point that I want to stress on. I have 344 kilograms per hour of feed, which contain 327 kilograms per hour of glycerol. I recovered 128 and recycled them, and I lost 199 kilograms per hour because I specified in the column that I want to get 128 kilograms per hour in the bottom as a bottom product. So that's why the rest is thrown away, 199, and I'm not making any use of them, and I'm recycling. So the recycle now has no point. There is no point of doing recycle if I am throwing out 199 kilograms per hour of glycerol while having the recycle stream recycling only 128. So the point here is that I want to make sure that the feed to the column, that this stream is the 128.8. It's not this stream is 128.8. This is the stream that must be 128.8, so that the flow sheet goes as I was planning in the before the recycle. And these are the values that I got before the recycle stream. And in this stream is just gonna be a makeup stream, so to compensate any losses in the glycerol either here or here in these two streams. So if I lose any glycerol here, this is gonna be compensated by the makeup stream here. So this should be small amount of glycerol. So to do this, I need to do one new design spec, asking the software to change this stream so that I can keep this stream as 128.8. So this is what I want to do. So I'm gonna call it the glycerol feed to the column or whatever. And this is glycerol feed, and the variable that I want to adjust is the stream variable, and this stream is the glycerol to column, and I want to adjust the mass flow rate in kilograms per hour. I want it to be 128.8, and oops, this is not the target. So the spec, again, we can open the variable list, and this is 128.8, and the tolerance will make it 0.01. And what I want to vary is the stream variable as well. The stream is the feed glycerol, and the variable is the mass flow. And here I don't want a lot of glycerol. This is just a makeup stream, so I'm gonna go from 0.1 to 10, which is almost 10% of the feed, or maybe less. So this might be, or this should be more than enough. So now we will run the simulation and see what kind of results we're gonna get after adjusting the flow rate of the glycerol fed to the column. So now it's done. I want to check the results of this stream, and this is going to tell me a lot actually, because it tells me that the amount of recycle now is 128. The feed I got from the glycerol recycle stream is 0.8, and the feed is 128.8. So it's now doing what I wanted to do. And now for the recycle, or maybe we go first to the extractive distillation. I have now the glycerol to column is 128.8. So it's exactly what I used to see before doing the recycle. And I have the ethanol purity is even higher, it's 99.7, because I'm using higher purity glycerol. This glycerol is even more pure than the glycerol I used in the fresh. The fresh was 99.5, this is 99.99, so it's even more pure. So it's giving better performance and better purity of ethanol. Um, and here for the glycerol recovery column, I have the amount of water 15.5, and I'm getting almost all of them in the top product, and the bottom product have almost all the glycerol I got. The numbers will be little different from what I used to see before the cycle, and this is expected because the feed is changed a little bit, so this is gonna have an impact on the outputs of the coming units. But it's the first thing is that it's getting better, so it's good in this case. And the second is not a big difference, so it's not making a problem or making issues with the required outputs. So I'm getting now the ethanol as I wanted, and I'm spending only money on 0.8 kilograms per hour on glycerol, and instead of spending money on 128 kilograms per hour. So it's a very big saving of money. And if I take a look at this flow sheet as just a black box, and I'm just seeing what's going in and out of the flow sheet, I have two streams, the feed of the glycerol and the feed, which is the ethanol water, the isotropic mixture, and I'm getting the output here as the ethanol, and I'm getting the output here as the recycled, I mean the water that I recovered from the glycerol recovery unit. So this is how we do the recycle. I'm just interested, or I'm more interested in the performing recycles in Aspen Plus. It's very tricky, and if you want to do it, you have to make sure that you understand very well what you're doing and how you can track any issues that you face. Of course, you'll face issues, especially if you have more complex flow sheets or something like this. Then you'll need to do more work and make sure that you adjust all the specs and all the parameters and all the variables. The procedure might be different if I use different specifications in this column or this column. So it depends on what you do and what kind of variable that you want to adjust so that the flow sheet is working the way you want it to work. So I hope it's helpful, and I'll see you in the next video, inshallah. Goodbye.